Hi, everybody. Oh no, this will never work for me the way it's supposed to. This is Mr. Folly, and welcome to an audio version, what's that you say, of 1.1. So let's hop right into it. All right, so moles and molar mass. Chemistry is done in moles. This may come as a surprise to you. You may think it's atoms, but it's not, it's moles. A mole is a grouping of atoms or molecules or ions. We call it indiscriminate grouping of atoms, molecules, ions, particles, meaning if we don't want to say atoms or molecules or ions, we'll just call it particles, okay? A mole is 6.02 E23 particles, which is this big number, and that makes up 1 mole. That's because particles are so small. The groupings are, this is made up by me, and it works really well, a handful. If I have a ream of paper, that's 500 sheets, that's a handful. If I have a gross of bottle rockets, that's 144, that's a handful, okay? Formulas are listed in number of particles, so that is pretty much moles. CO2 means 1 atom of carbon and 2 atoms of oxygen. Or it would be a dozen and a dozen, or a mole and a mole. But really, this is what we're going to use almost all the time. Okay? Moles are typically converted to from grams, as balances are easy to find and use. Yep. Molar masses are found on the periodic table, and that's this part right here. Okay? And that's the mass of 1 mole. Okay? So let's do a couple of math problemos. Let me get out my calculators. Here we go. So, copper 2 chloride. Bum, bum, bum. Oh, no. So, copper 2 chloride is CuCl2. So, the molar mass. So, copper is 63. I'm mad at myself because I left my periodic table on the other end. What is the molar mass of copper? 63 point something. 63.55. And the molar mass of chlorine is 35.45. How about that? Okay, but I have to do that one times 2. Okay, so here we go, calculator. Oh, no, my calculator is validating. So that means it's going to be 70.90 plus 63.55. I was stalling as my calculator validated. 70.90 plus 63.55. I got 134.45. And that answer will be in grams per mole. Okay. Magnesium nitrate. Magnesium, periodic table, 24.31. Nitrogen, notice I have 2 of them. 14.01 times 2. And then I have oxygen, 2 times 3, not add, times. 6 times, periodic table says 16, equals 6096. Add those together, 24.31 plus 28.02 plus 96 is 148.33 grams per mole. All right, so I need to explain what a hydrate is. So there are compounds that have water attached to them. So that means you literally have water molecules attached. So for every one of these, if I were to represent copper sulfate as a bloop, and I have 5 water molecules attached, and I made water be a dot, I would have 1, 2, 3, 4, and each of those would be water. And I'd put a 5th one somewhere, okay? So what that means is I have copper, again, 63.55, plus sulfur, periodic table, 32.07, plus 4 times 16, which is 64, plus, if you trust me, water is 18.02, 5 times 18.02. So let's do that. 5 times 18.02, enter, plus 64, enter, I don't know what I'm entering, plus 32.07, plus 63.55. 249.72. All right. So how many moles are in 3 grams of iron? So I'm going to start with 3.00 grams of iron times dividing bar. I'm going to put grams of iron on the bottom and 1 mole of iron on top. Now, the reason why this works is these things have to equal each other. Oh, they equal each other, okay? So 1 mole of iron equals 55.85 grams of iron. So whenever you do this, the unit that you want to cancel on the bottom. So if I have 7x over 3 times 5 over 2x. The x's cancel, right? So that's what we're doing, is we're canceling the units and just doing the math, okay? So 3 divided by 55.85 is 0.0537 moles. How many grams are in 2.51 moles of F2? 2.51 moles of F2. I'm going to emphasize the 2 right here. So the 2 means I have to double it. So fluorine is 19.00. So that means there's 38.00 grams of F2 in 1 mole of F2. I put it in the wrong spot. Shoot. 1 mole of F2, 38.00 grams of F2. 2.51 times 38 is 95.38 grams. You do need units, just so you know. Even if it's just moles, I should have moles of iron on there, but that's it. All right. Mass spectroscopy. No. Sorry, 1.2. So atoms are made of protons, neutrons, and electrons. So this kind of gets buried in here. Protons determine the identity. They're involved in mass and charge, but just know the identity. Neutrons determine stability and mass, and electrons determine the charge and reactivity. So if I'm looking for this, the element symbol, if it's boron, we typically have the mass on top, and we're going to have the number of protons on the bottom. So what we're going to look at here is we're going to have the atom. Up on top is the mass. On the bottom is the protons. And over here is the charge. Okay. You need to know that mass equals protons plus neutrons. Okay. And you know that charge is protons minus electrons. Okay. So boron, atomic number for boron from the periodic table is 5. Good memory. Thank you, memory. Number of protons is 5. These will always be the same. Number of electrons, notice there's no charge, 5. Number of neutrons, 6. 5 plus 6 is 11. Nuclear notation would be boron, 11, 5. Hyphen notation, boron, dash, 11. Notice how that dash is the mass. Okay. Same deal right here. I've got 5 neutrons, so I know I have to have 5 protons. That always is, for boron, is always 5 and 5. So if I have 5 neutrons, that's going to be 10. Element name is still going to be boron unless it's negative. Oh, but it is. I have 8 electrons, but only 5 protons. So it's negative, so it's going to be boride. I just misspelled bore again. Boride. Okay, so negative ions are evil and end in ide. Okay, mass number is protons plus neutrons. 5 plus 5 is 10. Nuclear notation would be B negative 3. Its mass is 10, still 5 protons. And hyphen notation would be boride dash 10. Okay. If your atomic number is 36, oh no, I'm really hurting not having my periodic table here. So let me think for a second. So atomic number 36 is krypton. So krypton. And the element symbol for krypton is Kr. Number of protons for krypton, remember, is the same as atomic number, 36. The mass number is 84. That means my neutrons are 84 minus, 36. So 84 minus 36, 48. And the nuclear notation is going to be krypton. The mass number is 84, 36. Hyphen notation is going to be krypton, dash mass, which is 84. Atoms of the same type may vary. They have the same properties except for nuclear stability and mass. We don't deal with nuclear stability at all in AP Chem, so that's good. There's no nuclear stuff in here. Isotopes are the same type of atom but have a different mass. Okay, my neighborhood has 2 dogs that look like mine. There's Penny, my dog is Penny, and what people call Fat Penny. Sorry, Fat Penny. It's not really fat shaming, it's just Fat Penny. Both are the same type of dog. Both poop on an old man's yard. Both bark at the Amazon driver, but one of them just weighs more. They're the exact same dog, except for Fat Penny is bigger. All right. Mass spectrum determines the number of isotopes and the abundance of those isotopes. The number of peaks tell you how many isotopes there are. So here I'm looking at magnesium, right? So magnesium has one, 2, 3 isotopes, right? And chlorine only has 2 isotopes. The relative height tells you the abundance. So it can't, so when you look at the relative height, there can't be 100% and 32, right? So that would add up to 132, right? So some of them, when they do relative height, it would be like 66 and 32, right? So LT doesn't allow 132%. The bottom number in blue shows the percent abundance. So this right here is the percent abundance, 78, 10, and 11. The top number shows the intensity, okay? So the abundance is going to be in blue, 78, 10, and 11. So this is, let's just call this 80, 10, and 10. So that means this should be 8 times as big. These two are about the same size. Here's 1, 2, 3, 4, 5, 6, 7, 8. So that should make sense for the intensity part, okay? So this one's about 25. And this is about 75, so 25, 50, 75, okay? So that's how that works. Top numbers show intensity. I like chlorine 35 the best because, so it is 100% most common, and 37, a third as much, okay? So this is 100% awesome. This is only a third as awesome, okay? All right. Problem 1.2. An element composed of 3 stable isotopes, blah, blah, blah. It's found to be 15%. A1 is 15% of the time, A2 is 65% of the time, and A3 is found 20% of the time. Find the masses. Okay, so draw a mass spectrum of the element. So A1 is 15% of the time. So A1 is 50. So at 15% of the time, I'm going to do 50. And A2 is 65% of the time, which is 52. 52 is 65% of the time. I made it a little wider and like a more bar graph instead of the stick graph. And 53 is found 20% of the time. Boom, 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 boom. There you go. Mass spec. Identify the element in the problem. And I have to pause because I'm getting this done in the middle of lunch. So I'll be back.